Imagine stepping into a time machine, pressing a button, and watching the years blur past you. 1,000 years, 10,000, a million. Then, finally, 1 billion years into the future, what would you find? Would Earth still be the blue and green paradise you know today, or would it be a desolate wasteland? More importantly, would humanity still exist, or would our species be nothing more than a distant memory? The answers lie hidden in the vast and unpredictable forces shaping our planet and our survival. Let's embark on this mind-bending journey to uncover the secrets of Earth's distant future. In the next 10,000 years, Earth will experience profound changes, both natural and artificial. While such a span may feel vast to us, it is barely a blink on the geological timescale. Just as the Y2K scare once gripped the world with fear, a much larger challenge looms on the horizon: the so-called decamillennium bug. In the year 10,000 AD, many of today's digital systems, still reliant on 4-digit year codes, will face a major computational failure. However, with the exponential growth of technology, it's likely that artificial intelligence and quantum computing will render such an issue trivial. Meanwhile, humanity itself will undergo dramatic transformations. The mixing of global populations will gradually blend genetic traits, making physical distinctions like skin color and eye shape less pronounced. Cultural identities may persist, but the regional genetic differences that once defined civilizations will fade into history. Yet, as technology advances at an unprecedented rate, will we even recognize ourselves as human? The line between biology and machine will blur. With AI seamlessly integrated into our lives, cybernetic enhancements becoming the norm, and even the potential for digital consciousness, our very definition of humanity may shift. Will we remain flesh and blood, or will we transcend our physical limitations, evolving into something entirely new? The next 10,000 years may hold the key to an existence we can barely begin to imagine. 50 million years from now, the world will be unrecognizable. The continents will have shifted dramatically, altering the face of the planet beyond recognition. Africa will crash into Eurasia, closing the Mediterranean Sea forever and giving rise to a colossal mountain range that could surpass the height of the Himalayas. Meanwhile, the Atlantic Ocean will continue to widen, pushing the Americas further away from Europe and Africa. In the Pacific, the relentless movement of tectonic plates will submerge the Hawaiian Islands beneath the waves, erasing them from the surface. However, the cycle of Earth's geological activity ensures that new volcanic islands will rise in their place, reshaping the oceanic landscape in a continuous process of destruction and creation. Beyond Earth, Mars and its moon Phobos are destined for a cosmic catastrophe. Phobos, locked in an inevitable death spiral, will inch closer and closer to its planet. Eventually, the gravitational forces will tear it apart, sending debris into orbit around Mars. Over time, this material may coalesce into a striking planetary ring system, reminiscent of Saturn's iconic rings. The collision will unleash violent impacts on the Martian surface, potentially altering its thin atmosphere and disrupting any future human settlements. If humanity still exists in this distant future, survival will depend on our ability to adapt to entirely new environments, perhaps not just on Mars, but on other planets or even artificial habitats. Millions of years of evolution and technological progress could lead to spacefaring civilizations that barely resemble the humans of today. With extended time in low-gravity environments and exposure to different planetary conditions, future humans may diverge into entirely new species, each uniquely suited to the worlds they inhabit. Our descendants could be unrecognizable, thriving across the stars in ways we can only imagine today. 500 million years into the future, Earth's biosphere will face serious threats. All continents will merge again, forming another supercontinent called Pangaea Ultima. This landmass will drastically change ocean currents, leading to climate shifts that could trigger mass extinctions. As weather patterns shift unpredictably, once thriving ecosystems will collapse, leaving behind barren landscapes and inhospitable conditions for life. The resulting climate upheaval will drastically alter biodiversity, pushing many species to extinction while forcing others to adapt in extreme ways. Over time, Earth's atmosphere will lose its free oxygen. Photosynthesis, the process that supports most life, will slow and eventually stop as plant life struggles to survive. The depletion of oxygen will set off a chain reaction, making it increasingly difficult for most organisms, including complex life forms, to breathe and sustain themselves. With the death of plants, the entire food chain will collapse, and even the most resilient species will face an uphill battle for survival. If humans are still on Earth at this stage, they will need artificial habitats with oxygenated environments to sustain their existence. To make matters worse, a gamma ray burst from a distant star could strike Earth without warning. These bursts are among the most powerful energy releases in the universe, capable of obliterating entire planetary atmospheres in moments. If such an event were to occur, it could strip away the ozone layer, leaving Earth vulnerable to deadly radiation from the sun. With no protection from harmful UV rays, the planet's surface would become a scorched wasteland, accelerating the extinction of the remaining life forms. The combined threats of supercontinent-induced climate change, atmospheric oxygen loss, and catastrophic cosmic events would make Earth an almost unrecognizable and uninhabitable world. By this point, Earth will be almost unrecognizable. The sun will be 10% brighter, causing Earth's average temperature to soar to around 47 degrees Celsius, 117 degrees Fahrenheit. The heat will be unbearable, and the oceans will have mostly evaporated, leaving behind vast salt plains and desert landscapes stretching across the planet. Once thriving rainforests and oceans teeming with life will be long gone, replaced by a hostile wasteland where few, if any, biological organisms can persist. Complex life, as we know it, will be extinct. The last remnants of bacteria and extremophiles organisms that can survive in the harshest conditions may cling to existence in underground reservoirs or deep within the planet's crust, but their time will be running out. The lack of water and oxygen will make it impossible for even the hardiest species to survive. Without a functioning biosphere, Earth will resemble Venus more than the blue planet it once was, its skies choked with thick clouds of dust and toxic gases. The pressure and heat at the surface will make it inhospitable to any form of advanced life. If humans survive, they will have long since abandoned Earth, fleeing to artificial habitats in space or colonizing distant worlds. Mars, with its underground cities and terraformed domes, could serve as a temporary home. The moons of Jupiter and Saturn, with their subsurface oceans, might provide a last refuge. But even these locations will be stepping stones to a greater destiny: humanity's expansion beyond the solar system. Perhaps by this time, we will have evolved beyond physical forms, existing as digital consciousness, transferred into synthetic bodies, or even harnessing the power of quantum computing to transcend biological limitations. Our descendants, if they can still be called human, may no longer be tied to the constraints of planets at all. They could roam the universe as data, traveling on beams of light or existing within self-sustaining megastructures orbiting distant stars. The fate of Earth may be sealed, but the future of intelligent life could lie far beyond the boundaries of our dying home world. This journey into the future teaches us a valuable lesson: Earth will not last forever. The forces of nature, from the relentless march of plate tectonics to the inevitable expansion of the sun, will reshape and eventually render our home uninhabitable. If we wish to survive as a species, we must look beyond our fragile planet and embrace the challenge of interstellar travel. The key to humanity's endurance lies in our ability to adapt, innovate, and explore. Our ancestors once ventured across vast oceans with primitive boats, seeking new horizons. Now, our next great voyage must be across the cosmic ocean, reaching for new worlds among the stars. Whether through generation ships, cryogenic stasis, or technologies beyond our current understanding, our survival will depend on taking that leap. The future may be uncertain, but what remains undeniable is the urgency of this mission. The clock is ticking, and the universe will not wait for us to be ready. If given the opportunity to glimpse a billion years into the future, would you dare to see the fate of our species? Or would you choose to stay in the present, working to shape the destiny of humankind before time runs out?